Right, I'll start off with the original parts that I didn't make. This, I was going to use this worm wheel from a 50 to 1 reduction gearbox. Indicator stuck to the chuck, indicated off this face, made sure it was true, bored it out. When I stuck it on the expanding mandrel when I stuck it on the expanding mandrel to check it, it was running true, but the actual teeth weren't running true. The blank was turning true, but the teeth had got a slight wobble on it, so whoever made this gear originally, they didn't index it in when they were cutting the teeth, so the teeth slightly wobbly, so I had to make another one. This is the one that I made. I decided to go with a different tack. I've got the expanding mandrel already, so I made that part, the tapered part that the gear was going to go on. Got a bronze. Thankfully, I've got a chunk of bronze already. It's slightly too thin. Diameter was slightly too small to make a proper worm gear how this is. The outer diameter was just a tiny little bit more than the outer diameter of the minor diameter of the outside teeth, if you get what I'm talking about. You can see the diameter slightly smaller, so what I had to do is I had to make an angled spur. So technically for this application that is fine, that is good enough. So I made this part, bored out the blank, pressed it on, and it's a good job I did it this way round because I got it slightly misaligned. You can see there, just that section there where it's silver. Got it slightly misaligned on the plates on the hydraulic press, and the plates, the V on one of the plates just caught the edge and peeled it over. So that's like key. Took 6 tons of pressure and slightly made it cockeyed on this. There is a slight gap on one side. But thankfully it took 6 tons of pressure, it's got a key so that is not moving. And then what I did was I put that on the expanding mandrel, stuck it in the lathe and then trued up the side, both faces, and trued up the outer diameter so that runs nice. And then I use that to index with a dividing head at a rate on a horizontal on the mill that I'm going to be showing. There's obviously a vertical mill, and I angled it upwards by the set angle that I needed to make the teeth angled. I'll get the terminology right in a minute, and then that's perfect for the worm gear. Now this worm gear as well, I had to turn that between centres. I'd already got the centre points, thankfully, just to knock the these back a little bit, these shoulders back, to make because the shoulders were about that wide. I had to knock them back a little bit for the bushings. So that's those parts. That, if you are making an expandable mandrel, by the way, turn it to the right diameter and then tighten that down to expand the end, and then turn it to 30 again. Make sure that front edge matches that, and then when you slacken it off, that becomes less of a diameter. Put the blank on, and then when you tighten it back up, it's holding at 30 at both ends. Or whatever diameter you want to use. That's the section that's going to hold the handles. That's keyed. That isn't keyed. And then you'd have it separated for using the mill normally, and then you clamp it down with a bolt, and then the worm gear will drive this, which then drives the spindle holding the pinion gear. That's the bolt. Just a simple bolt with a nail on it and a wide shoulder. That's a modification. I started making all this and then I thought, well, this isn't going to work properly. The reason why is that was designed to push. There was going to be a spring on the inside to pull it out. But the problem is the spring wouldn't be contacting this and that would just be slopping about. So I had to think on my feet and I made another part to go over the top of that with a recess on the back. And that is bolted. That is bolted to that, and then when you unscrew that, it pulls it out of the way and holds it out of the way. That is, I can see a potential error. That is screwed. So obviously when you're turning this, that might screw and unscrew. But the shaft that this is unscrewed with, the shaft that this is screwed into, this is keyed to it. So as you turn that, the shaft's going to be turning with this screw, so it might tighten, it might not, I don't know. I haven't got a spring yet, but if it does prove to be an issue, I can always put a spring in there. So that's those parts. I turn that on the expandable mandrel as well. That's the original part that I made that screws on. It's got a left hand thread because as you turn it, it's turning that way when you're putting pressure on, when you're tooling, when you're down feeding, you're turning it that way around. So if it was a right hand thread, it'd unscrew, and then that's the section that I'm going to put the spring in, and then the bolt screws in. And then the spring on the inside will push against that, which will pull that tapered section away with the handles on it. That is a bodged key slot, and thankfully I didn't make an error. The original, well, you don't thankfully make an error, but I made an error with that key slot slightly, so it's a good job that I did have to make another part. That's the original spindle from the mill with a pinion gear on it. Originally that's where it ended. It just sticks out a slight section from the mill. It goes down to 1 inch diameter for about that long, and it's just a plain shaft for the handle to slide onto and then pin to for winding the spindle up and down. The pinion up, turning the pinion. What I did was I turned that 25 down to the internal thread, the left hand thread that was going to screw onto. Screwed it on, indicated all that lot in the lathe just to check it, and then that had got quite a bit of wobble on it, which I didn't think about at the time, but it's obvious that was going to happen, so I had to throw that piece. Make another piece with that left hand thread in it, screw that on and then indicate that in, and then turn this part down to the 30mm diameter that I needed, and then bore it out and thread it like I did the other piece and make a much better key seat. I filed this key down a little bit so it's a nice slip fit, because with that key on you can't put this on, so it's like a woodruff key. Slide that on first, then you put the key in, and then you put that section on then. I could potentially make a full shaft, but there's a lot of operations and gear teeth cut in, a slot there for the spring, a circlip groove, clip groove on there. There's a lot of operations when that potentially works. Now, I've Loctited this on before turning it. If there is a problem, I need to revert it back to how it was originally. It's not an issue. I can always just chop this off from about there, turn this diameter down to the 25mm inch that it was, and then just put the original handle on. That's the box. Move all this lot out of the way. This is the gearbox. Turn that all from one solid block. This thrust bearing here, angular contact bearing, was another afterthought. And I was worried a little bit, to be honest, because I've made that shaft 30mm diameter, and the standard, if you get a thrust bearing, angular contact bearing that's got a 30mm internal diameter, the outer diameter is 47mm. Same as normal, like roller thrust bearings or needle roller bearings or anything, they always seem to be 30, 47. This is the only bearing that I managed to find, and for some reason it's advertised as an earphone bearing. Why I'd want a bearing in a set of headphones, I don't know. But that's 30.2mm internal diameter and a 43mm outer diameter. So thankfully it doesn't overlap the actual mounting holes. That's pressed in, and then the back of this, where you put the pressure on for the drive, that section there is turned down slightly. The outside diameter is turned down slightly, so it only contacts the inner race of that angular contact bearing. So when it's turning, there's no friction there. So that's how that works. Got the measurements wrong for these. They're a little bit too high. They needed to be down by about 1.5mm. The good guy mentioned bushes, eccentric bushes. So I made these eccentric bushes so I can stick the... I'm putting those in the wrong way around. No, they do go in. So I can put those in. They do fit perfectly, so I think there's some crud in there now. You put that in, obviously you just turn those and adjust the backlash, and the backlash is now perfect. Those, once you get the backlash right, the wall thickness was too thin to put set screws in, so I put them a little bit higher up and about 45 degrees down. So once set, you just tighten those grub screws down. I'm not going to be able to get those out now, am I? Oh, fun and games. That's how it's going to be mounted on the mill. So this is on the outside of the mill, and that's the whole spacing, the whole pattern that I needed. And that's why I was worrying, because if I had to put a bearing in there that was too wide, I wouldn't be able to mount it at all. So it was either have that or no bearing at all. Or some kind of fibre washer. Thankfully hand wheel that I already had. I turned the boss down a little bit to put this aluminium pulley on. That's pressed on. That took about 2.5 tons of pressure to push on. I might stick a couple of set screws in there as Dutch keys. I don't know yet, but there's not a lot of force going into that, so if there is an issue I can always do it at a later date and put a hole in that already for a handle. And it's obviously, because you're going to have all that lot sticking out, you're not going to be able to get a lid on and off. So I've had to make a two-parter, which works quite well, because then I can take that top section off and fill it with oil. I've got an oil trough 3D printed. You stick the gear in like that, and stick it in, and then when that's the right way up, obviously, otherwise the oil's going to spill all over the place. You can drip oil into there, or fill that with oil. When that's rotating, that'll just feed the oil up to the worm gear at the top, and keep it oiled as it's spinning. And then when it's not in use, it'll just drip back down into the trough. What else is there? I think that's it, to be honest. So now I'll get on to the construction, showing you how to how I constructed that was. Like, there's no motor mount yet. I want to get all this lot up and running, and I can always use the hand wheel for the fine feed or the normal feed. The normal handle for the normal feed. And then work on the motor plate and the motor and all the wiring and everything. So I'll get on with that now, the construction, and get a mill back up and running properly. Can you see the error yet? Oh dear. I might be very, very lucky. I'll just get a slightly, take the diameter down. Myford, they didn't do the whole pattern level. And I should have seen that coming. That's one thing that I should have checked out. That box, I can't get it level. It's cocked that way slightly. So this is obviously raised. Right, I've fixed it. Fixed the issue. It's cocked over by 7 degrees. So what I did was stuck it on the rotary table. You might see it. Can you see it? No. Stuck it on a 300mm wide rotary table, and I couldn't take the bearing out. I couldn't press it out from the back because it's not going to contact bearing. If you put pressure on the inside race, you just smash it to pieces. So I had to carefully mill around the outside of it with the bearing still in. Thankfully there's a bit of space. See that wall wound there? I was turning that, and that corner's there, it's quite sharp. So my own work, butchered myself with my own work. So I made the slots 7 degrees. I rotated the rotary table 7 degrees to make the recessed holes 7 degrees further round, so I can tilt this round. Also, if you've got a VMC or a clone, you want to do something like this. This top lid, the top box and everything is held on, is bolted down to some bracket, so there's a bracket in the way just here. So I have to mill the corner of the box away at the back. But only a slight bit, just to give a bit of space, bit of clearance. So now that is 89.9 or 90 degrees. I call it 90 degrees, it looks it. I can now get on with it. Right, I was a dumbass. Put the screw in first and then put the bushings in. Easy. I'll go and rotate this right. That's it. Easy as can be. Put a little bit of oil on that. Hands are a bit shaky. Just adjusting the backlash now a little bit. Get the backlash right. So I've got to find the key. Oh, there it is. Is that the... That's it. Come back to you in a bit. Oh, put a little bit too much in there. It's working well. Don't know if you can see that, that's oil being scooped up and it's dripping down the side and the back of the gear. So it's nicely oily. No backlash in the screw. I didn't mention it, I'd made a dowel ring washer, small dowel rim washer that fits between the worm gear and this bushing. Just fits behind, just to take a little bit of slack up, so there's no backlash on that now. Make a domed nut for this, so effectively it's like bringing two nuts together. That's screwed on, the nut will screw on, and then while I'm holding that I'll just tighten the nut up to it so it doesn't come loose. Space at the top to slip a belt over when I need to, and then when I take the motor off and everything I can then set the belt off, so the belt and the motor's not hanging there permanently, because the motor's going to be underneath here, so it could be in the way for fixtures when I'm not boring. So the whole idea is you can put the motor on and you can take the motor off. That's working really well. First put the lid on. Here's where I find out that I haven't made that hole big enough. The hole through the lid. Because it starts to, the part here at the back that holds the worm wheel starts to taper outwards before this surface. It's a little bit further in. If that makes any sense whatsoever. That's the wrong size screw. Ta-da! That's only took me about 2 months of planning and making. This is turning at the moment. Oh yeah, the back's turning. I'll tighten that down, loosen that back off. So that's turning. That's turning for the power feed and for the fine feed. I just want to, when I want to just use the quill feed, the normal coarse feed, the handles will be in opposite way, you can see it, the way to the, I'll just move the spindle up and down by hand. Now, so when it's locked up, it won't move up or down at all, because the worm wheel can't drive the worm gear. So now what I've got to do is I've got to make the handles for it. Handle for this, the nut, and then start on the motor mount and everything. Right, I've now got the motor mount on there. I didn't record any of the machining because it did take a long time. I was thinking as I was going along. I've got the motor mounted on there. I have to excuse the focus because it's on manual focus and I'm moving the camera around. We've got an M10 stud, M10 1.0 for a fine pitch so it's stronger, and a nut there that I've made. That motor mount is just a 6mm thick plate, curved. I had this sticking up, I designed this to stick up to have another stud there with a curved slot in the motor plate. I might still stick one on, but that M10 1.0 thread is that tight, there's no movement on that at all. So I might just leave that how it is. I might design like a cap that I can screw onto this pulley to make that look a lot better, because that looks a bit rough. But the way this is powered, that plug there is 240 volts AC, and it converts the power, it transforms the power down to 24 volts DC. That goes into the controller. It's a PWM controller. That's the on-off switch, and then that's the speed control. The maximum speed on this is 19 RPM. Make sure that's disconnected. That's the maximum speed. And then all I've got to do is, you've seen on the previous section of the video, you just tighten that down to get the feed. I've had this off because I was recording it for someone else, and I was showing the oil coming from the oil trough because somebody else 3D printed that for me. And it's all up and running. There are a few little bugs. For some reason I've got no clue why it happens, because all this assembly and the spindle through and this nut all spins together. But for some reason when that's tightened down, it gets to about a third of the rotation and it loosens off. So I can tighten that down as much as I want. After about a third of a rotation, I can then turn that about another third of a turn. So for some reason that's coming undone, and I don't understand why. Now, if this on its own was rotating and nothing else, I'd understand why, because there's friction there. So as you're turning that anti-clockwise, that's going to unscrew itself. But the shaft that goes through with the pinion, everything is turning together, so I've got no clue why that's undoing itself. So that'll be a part 2. I've got to figure out how to get this so it doesn't undo. For now though, I can bore, and all I've got to do is every now and again just nip that up. But I'll set it up now, position, so you can see it all in motion and all working. Right, this is the wrong boring bar. I need to tighten this shed up. I can't find the boring bar for the full depth, so I can only go about 30mm down. So yes, 0.4mm depth of cut. I hope so. I'll put the power in for the mill. That's tightened up. Put my glasses on. I need my glasses on, not chuck them on the floor. That's it. Get some air on that. Now I'll do a closer view. Job's a good one. It won't focus in closer than that, so I can't show you the actual quality of the bore. I'll move that down before I stick my finger in there. But that is 100 times better than the surface I was getting when I was manually feeding. Like I say, that insert, I don't know if you can see it there, I've got some light on it. It's not the best insert, it's not the best boring bar either for it. A brazed carbide or HSS would be better, but for the tooling that I've got and the tooling that I can find, that is pretty damn good. I'm going to stop it how it is because I haven't been able to go down as far as I wanted to do. That hole is going to be a little bit bigger. I need that hole about 1 1/4 inch, and at the moment it's around 20 to 29 millimeters, which is 1 1/4 inch is 31.75. So it's getting close to the final diameter that I want it. So I'm not going to go any more with that boring bar. That's it for this video, and I'm more than likely to do a part 2 when I've worked out any issues, what the issue is, this disconnecting. I've got a thrust bearing on order. I'll zoom out. I'll explain what that thrust bearing is for. That thrust bearing is going to be for between this bolt head. I'm going to make another one of these that's wider and not a nail. It's going to be a proper wheel so I can get a bit more torque on it. And I'm going to stick a thrust bearing in a couple of washers, just a needle roller bearing between this register and this. So as you're tightening up, it's similar to like a ER40 collect nut. You can get them with a thrust bearing or without. With, it's a lot smoother to tighten and you can get a bit more torque on it with a bearing rather than without. So it's two metal surfaces rubbing together when you're tightening, it causes friction, it binds up a little bit. Get a bearing in there, you can turn it probably about another third of a turn. So I've got one of those in order, so I've got to remodel that part to make that slightly deeper, because that currently is about 5mm thick, about 6mm thick, and the combined needle roller thrust bearing and the two washers either side I don't know, about 1/4 mil thickness, so that needs to be a little bit thicker, and for that reason that needs to be a little bit deeper and a little bit wider because it's 35mm diameter. But enough waffle, the power feed's working, not 100%, but it's there, it's workable.